In the last classes, we discussed Thomson model, Rutherford model and Niels Bohr model. But Niels Bohr model was incomplete because there are so many rules are there which exhibiting different types of properties of the atomic model and its behavior. Okay. In last class, I had told you that according to Niels Bohr there is a nucleus and there are shells. And each shell is named K, L, M, N. And for shells, to know the total number of electrons in any shell, the formula was 2n square. And for the value of n, 1, 2, 3, 4, continuous. The 1 was for K, the 2 for L, 3 for M and 4 for N. If you want to know the total number of electron in any shell, you just have to put the value of n in this place. 2 into 1 square or 2, 2 into 2 square or 8, 2 into 3 square or 18 or 2 into 4 square or 32. So 2 electrons can be present in K shell in any condition. 8 electrons can be present in L shell. 18 electron can be present in M shell and 32 electron can be present in N shell. What does that mean? It's not mean that there is an orbit shaped like this which have contained 32 electron. There is an orbit like this which contain 18 electron or 8 electron or 2 electron. No, not that type of. These are shells. These K, L, M, N are termed as shells. But there are types of shells which we called subshell. Means there are these, you conceive this as a society. These are homes in that society, and within each home there are rooms. जिस तरह से घर में बहुत सारा रूम होता है, just in the same way in a shell there are so many rooms, and that rooms are called subshell. And this subshell are in especially 4 parts: S, P, D and F. These are called subshell. S means sharp, P for principal, D for diffusion, F for fundamental. So subshell has 4 types: sharp, principal, diffuse, fundamental. Okay, SPDF. In S subshell, 2 electron can relay. Only 2 electron, no more than 2 electron can stay in the S subshell. In P subshell, 6 electron can exist. No more than 6 electron can exist in the P subshell. Yeah, less than 6 is possible, but no more than 6 electron. In the D subshell, 10 electron can exist, and in the F subshell, 14 electron can exist. Actually, if you see in the periodic table, there are 4 blocks: S block, P block, D block and F block, which I told you when you were in last class, in class 8. So in S subshell, no more than 2 electron can exist, or it has a capacity to hold 2 electron. P subshell has the capacity to hold 6 electron. D subshell has the capacity to hold 10 electron, and F subshell has capacity to hold 14 electron. And according to this basis, we have developed a system, and that system is called electronic configuration. And that electronic configuration tell us exactly how many orbits are there and how electrons are distributed according to their energy level. That why I just said energy level? Because the energy in each shell is different. The energy of each shell is totally different. How it's different? The electron which exists in the nearer portion of nucleus has less energy but the electron which exists in the outermost orbits have highest energy, highest level of energy. I want to tell you that in any nucleus there are so many orbits. There are so many orbits, and in each orbit there are electrons. In each orbit there are electrons. But energy of all these electrons are not same. The energy of electron which is nearer to the nucleus has less than the energy of the electron which exists in the second orbit. So as you go one orbit up to up to up to up, as you go up from one orbit to second, second to third, third to fourth, fourth to five, the energy level will also increase. So the electron which exists in the outermost orbit has highest level of energy than the electron which exists in the nearer orbit. So according to this you can write like this: E4 is greater than E3 is greater than E2 is greater than E1. That's why we can easily remove the electron from the outermost orbit, and it is very difficult to remove the electrons from the lower orbits. Okay, these are called lower orbits, this is called higher orbit. K is lower orbit, L is higher orbit, but L is lower orbit according to M, because if you compare L and M is higher orbit, L is lower orbit. If we compare M and N, then N has higher orbits and M has lower orbits. So if we compare then, but if we compare about the level of energy, then as you go from here to here, or from here to here, or from here to here, energy will also increase. Energy of what? Energy of electrons. Energy of electrons will increase. Okay, how it increase? There is a reason behind it. Suppose this board is a magnet. Okay, and now suppose in this room there are so many benches. I give you top means lattu. I give you 5 tops, all made by iron. Okay, iron. We all know that iron is attracted by magnet, because iron is a ferromagnetic material. So if you put all those 5 tops at 5 different points from the board, and you spin all those with the same speed, with the same energy, you spin them with the same energy. Tell me, which top will spin fastly and for long time? We all know that the top which is near to the board, which is near to the magnet, will spin slowly, and the top which is far from the board will spin fastly, because this magnet board, which I am supposing as a magnet, will attract less to the far top, and it will apply a strong magnetic field to the nearer top. Because of the strong attraction, the top which is near to it will spin less, and the far top will spin more. And we all know that if your ceiling fan is rotating slowly, you can put your hand there, but if it is rotating very fastly, can you put your hand there? We all know that if your fan is moving very fastly, it has high amount of energy. If it is moving slowly, then it has less energy. So we can know the amount of energy which is less or more by knowing the rotation of any material, rotation of any electron, rotation of our fan. So just in the same case, all electrons not only revolve around the nucleus but also spin on their own axis. There are 2 types of motion executed by electron. This is electron, this is electron. It not only spin about its own axis, electron not only rotate about its own axis, but it also revolves around the orbit. So it has 2 types of motion: orbital motion, orbital angular momentum, and a spin angular momentum. It spin on its own axis and also to the orbit respective to the nucleus. So 2 types of motion, but the energy level of any electron can be known by knowing its rotation, because the higher the energy of the particle will be, the higher its rotation will be. So rotation will be higher if energy will be higher. So From here we are done. Now I was telling you that the energy level is different. Energy level of E1 is less than E2, E2 is less than E3, E3 is less than E4. So the electron which is in higher orbit will have higher energy and the electron in lower orbit will have lower energy. So the topic initially was about shell which we called KLMN. These are shell, and to know the exact number of electrons we use 2n square formula. And the shell had many types which we call subshell, and subshell had many types S, P, D and F. And what S, P, D, F can contain electron? I told you that S subshell can hold 2 electron, P subshell can hold 6, D subshell can hold 10, P subshell can hold 14. But the formula by which they hold, the formula which we use to know the exactly how many electrons are there, how we can know the electrons distribution, how we can know how many types of orbits are there, how we can know then which electron is present in which place. We use a simple but meaningful formulation which I am going to write here, which you will write. The formula is 1s, 2p, 3s, 3p, 3d, 4s, 4p, 4d, 4f, 5s, 5p, 5d, 5f, 6s, 6p, 6d, 7s and 7p. This is the formula we can use. With the help of this to calculate how many electrons in any atom are there and how they are distributed along it. Okay, this will help us to calculate the total number of electrons and also will help us to know the valency of any valency of any atom, whether that atom will give out its electron or will receive its electron. And we know and we will learn how the electron donating or electron accepting characteristics will point to its metallic character or non-metallic character or metalloid character. Okay, we can know the exact property of any element by calculating its electronic configuration. Okay, so in this class we are done. You just write it up, and in next class we will learn how to make electronic configuration of any element. Especially we will learn first of all S and P block, okay, in linear method, and then we will use cross method when you will come in school. Okay, till then.